Okay, so this is your SVATD worksheet. We're going to be doing number 7, number 8, and number 10 together. So let's look at number 7. You're going to take your highlighter. It says, how long will it take to travel 200 kilometers traveling 100 meters per second? So what I want you guys to do first is take your highlighter and pick apart the problem. How long will it take asks what? What am I asking you? Yeah, if I ask you how long is something going to take, I'm asking you time, right? Okay, so how long will it take? I'm asking you time, and then I'm picking through and I'm finding the important stuff. 200 kilometers and 100 meters per second. The next thing I'm going to do is I'm going to list what I'm given. Time equals, I don't know, because that's what I'm looking for. I'm being asked how long will it take. So time equals question mark. 200 kilometers. Based on the units kilometers, what is this? Distance. It's a distance. So I'm going to say D equals 200 kilometers. And then 100 meters per second. Based on the units, it's a what? It's a velocity or a speed. Okay. Okay. So I've listed what I have. But I have to be careful here. Everybody look. My distance is in kilometers. But the distance part of my velocity is in meters. So that's like apples and oranges. You can't do that. So I'm going to have to convert something. And personally, I think it's easier to convert the distance than it is to try to mess with converting the velocity. You guys got it? So I'm going to take that 200 kilometers. Does anybody know how many meters are in a kilometer? There are 1,000 meters in a kilometer. Okay, so I set it up like this. It's kind of like multiplying fractions. So like this is a fraction, this is a fraction. 200 times 1,000 is what? Oh my gosh, 200 times 1,000. It's 200,000. Okay, and look, I have kilometers on the bottom, canceling kilometers on the top. So 200 times 1,000, that's 200,000, divided by what's on bottom, but what's on bottom is just 1. So this is just 200,000 meters. Okay, so I can put it over here. 200,000 meters. Okay, so I'm going to make sure that I use the 200,000 meters rather than the 200 kilometers. Does everybody understand why? Yes. It's because my speed is in meters per second, so my distance needs to be in meters also. Okay, so now I look at the sheet that you did for notes the other day. Find your formula to solve for time. And tell me what it is. Distance over speed or distance over velocity. Okay. So I write the formula. And then I'm going to write the formula again with the numbers substituted in. T equals 200,000 meters divided by 100 meters per second. All right, everybody look up here and tune in. I don't know if anybody's taught you this trick, but if you're doing division and you've got zeros, spare zeros, cancel a pair of zeros, cancel another pair of zeros, and now it's just 2,000 divided by 1, isn't it? So what's your answer? 2,000. Okay, so T equals 2,000, and y'all watch. Meters cancels, meters cancels. What's the only thing I have left? Seconds. So, and that makes sense because I'm solving for a time. So time is equal to 2,000 seconds. The big trick on number 7 was to make sure that you had to convert the distance into meters before you could do anything else. Is everybody okay on that one? Okay, let's do number 8. Again, I'm going to read and highlight. If a rocket travels 5,600 kilometers in 3 hours, what is its speed? So pick out the important information. 5,600 kilometers, 3 hours, speed. Write everything down. Speed equals question mark. 5,600 kilometers is a distance. Okay, so D equals 5,600 kilometers. And then 3 hours is what? That's a time. Okay. I go looking for a formula. I need a formula for speed. Speed equals what? Good. Distance divided by time. I write the formula again, this time with the numbers. And then I've got to do the math. So this is 5,600 divided by 3. Do you have to show your work? Of course you do. 3 will go into 5 once. With 2 left over, bring down a 6. 3 will go into 26 8 times. 8 times 3 is 24. You have 2 left over, and you bring down a 0. 3 will go into 20 6 times. 6 times 3 is 18. 20 minus 18 is 2. Bring down a 0. You've got 20 again. 6 times 3 is 18. What are we going to keep getting?
6.
You're going to keep getting a 2, bringing down a 0. You're going to keep putting 6s up here forever and ever and ever and ever and ever. It's never ending. Okay. So my answer is 1,866.6 repeating, but I need to round it off to 1 decimal place. So speed equals 1,866.7. And then I look over here, my unit will be kilometers per hour, which should make sense because kilometers per hour is a unit of speed. Put a box around your answer so that Miss Goff can find it. Good so far? Okay, can I move it up so we can do number 10? Alrighty. All right, number 10, what is the acceleration of a car that goes from 40 kilometers an hour to 80 kilometers an hour in 2 seconds? Pick apart the sentence. We're looking for acceleration. We go from 40 kilometers an hour to 80 kilometers an hour in 2 seconds. What are we looking for? A equals question mark. We're looking for acceleration. What do we have?
Speed.
Okay, so what is the change in velocity? You started at 40 and you ended at 80.
40.
Okay, so I'm going to put triangle V, the change in velocity. You ended at 40. Sorry, you ended at 80. You started at 40. That's a change of 40 kilometers per hour. And what else are you given?
The speed or second.
Time, the seconds. Okay, time equals 2 seconds. All right, now we go looking for a formula. I need an acceleration formula. Acceleration equals super duper change in velocity over time. Write it again, this time with the numbers in it. My change in velocity was 40 kilometers per hour. My time was 2 seconds. I'm going to go out on a limb here and say y'all can probably do that math in your head. 40 divided by 2 gives me what? An acceleration of 20, and then watch your units. Kilometers per hour per second. Meaning that this car is changing its velocity by 20 kilometers per hour every second that it's accelerating. So it was going at 40, and then it started to accelerate. And after 1 second, it was going 60. And after another second, it was going 80. Because it's picking up speed at a rate of 20 kilometers per hour every second. Are we good on this one? Okay, so just to make sure, flip back to the beginning, the front page. So I'm going to end the screencast because the first screencast did number 2, number 4, and number 5. But for this class that I'm currently doing, we need to go over those. So.